Do you know any shops? Do you know any tire shops around here?
Yeah, she works at one.
Here? Around here?
There's a place over there down that Hornhill Road where you can get used tires.
You think I don't need it? I don't want new tires.
You don't want new tires?
I want new tires.
You want new tires? Well, down at the end of the street, the Exxon.
You didn't have my tires?
Probably. They stock a lot of tires and all that. So.
They're like low profile.
Yeah, you'll be all right. I
Pretty
mean,
light.
well, we'll hook you up fast. All right. I worked at a while at a shop called Davis Auto Service, and this guy that was he was 6 years older than me when I was working there, and he was basically real good troubleshooter. He was always, and this Monte Carlo was almost brand new, and he says, I'm going to take off over here to the down Bellwood Road, and he says, and if I'm not, he said, this thing's quitting, and we're trying to figure out why it's quitting, and so he says, so what we're going to do is see if it quits on me, I need to be watching your watch, and if I'm not back in 30 minutes, you need to come down Bellwood Road looking for me, because I'm going to be sitting beside the road somewhere. And I said, okay. Instead of having me follow him, so anyway, I looked at my watch because I was doing some work on a car, and I looked at my watch, and it was like 45 minutes later. Oh crap, I forgot about him. So I jumped on the shop truck and I headed out. And so this thing right here,
Ignition module.
well, what it amounts to is like on our old 350 trainer, you got this little HEI 4-pin module, and it's got the coil is actually at the top of the cap. But the simple fact is, that module right there takes input from the reluctor in the distributor in the pickup coil, and then it fires the coil. So the deal was, he was going to check for spark while I was out the road with him, and so he forgot to bring something to check for spark with. So he looked in the back of the shop truck, which is an old '66 Chevrolet pickup we had out there, and he got a piece of heater hose, about this long, and he slid it over his pocket knife. Right? That sounds pretty good, don't it? I mean, he don't check for spark, and he don't want it shocking him. So he, so he's taking that piece of heater hose, puts it over, and he's holding it out here, and he tells me to spin it over. Well, by that time, the spark has come back, and it fired him up, like that. And what he didn't realize was the fiberglass in that hose conducts electricity real good, and it just lit him up. But anyway, it turned out that one had a pushed back pin in the bulkhead connector, and that's why it was, dying like that. That's the old shop truck right there. See, and that's right. The bulkhead connector where it goes through it actually had a pushback pin, and that connector right there was an HEI distributor, just like we got out there on that one, because that was like a 75 or 6 model car at the time. Well, come and go wiring problems are really, really annoying. I mean, you start working on it and it won't quit working for you, and before the customer gets out of the side and stops to their favorite stop sign, it's done quit. You know what I mean? I mean, you work on it, trying to get it to quit, and then finally, it always quits for them. A lot of the times, the best way to handle something like that is just go ahead and take a test drive like you were driving it as if it was your car. Now be careful. You don't want them to find you at Hardee's or the credit union or something like that on your car, on their car, because they don't like that. Okay?
Why can't I go to Hardee's now?
Anyway.
Big boy got
Alright, so when a short or an open is consistently present, it's usually pretty easy to find it. If it's always there, it's usually pretty easy to find it. And some of y'all have done that kind of work here. And these really thick wire harnesses that are routed all over the place, this looks like spaghetti down here, doesn't it? Let me get rid of that sea cleaner update. All right. And so, anyway, so in a lot of cases, the smartest thing to do is get some loom and do a quality permanent overlay. Like for example, if you know that the power starts at this switch and it goes from here over there, then what you can do is go ahead and follow that with run a wire in as much as possible inside the loom if you can, because sometimes they'll have a loom you can go inside of. But make sure you keep it, if you're going to run it outside the loom, put it in some of that split loom that you can buy at the parts store. They even sell it at Harbor Freight. And make sure you route it where it's not in trouble. It's not going to get in trouble with getting wrapped around something and all that. And it's a little complicated though whenever you've got one that's going every which way, because everything, like if you're just going from here to here, everything has got to be fed on there. So if you got, you know, you gotta find out, it's best just to fix the one leg if it's got one. And so a lot of the times they do that. All right, so think of the wire harness like a nervous system on your nervous system is like a wire harness, right?
Yes.
All right, and so basically everything, all of these signals, all these nerve signals, you know, you got these little synapses in your nervous system where it puts acetylcholine out. And then the electrical signal rides across that little gap in that little synapse, and then cholinesterase stops that signal from going. Well, on this, you got switches, and you got relays, and you got stuff like that. All right, so, all right, the AC harness was damaged. I showed you this picture a while back, but this is the kind of thing I'm talking about. What we did was we found out that whenever we hooked the test light up to hot and we went to the relay that was supposed to be feeding the AC, we absolutely had no ground showing at all because it should have been coming through the compressor clutch back up to the relay. And somebody had managed to let this wire harness get unseated and get over against the belt. Now, one of the places where this happens in a dreadful way, and you don't even think about it unless you've seen it happen, is people will be pulling the timing cover off and doing the timing belt and all that kind of stuff, and you got to take the crank sensor harness loose, and you wind up with it too close to the belt because you didn't route it like it was supposed to be routed, and they get down the road a ways, and the belt is like a saw, and it's done cut the wires in two, and they're sitting beside the highway. You know, because you got to pay a real close attention to those wires and how they're going and the moving parts and the belts and stuff. That belt makes a dandy saw. It'll saw a wire harness in two. And a wire harness can rub against something like an air conditioner line, and it can actually rub and rub and rub on that air conditioner line and not even rub a hole in that air conditioner line, but work its way into the harness. You know, and the harness and you wind up with all kinds of different electrical problems. We got a bunch of crazy electrical problems. You know, look for a place where there's a big stiff harness is laying up against something where it's doing this every time the engine torques. That's really important to, you know. But it's a whole lot better too if it's an intermittent problem. Don't pull on anything, don't jerk on anything, just look and see with your flashlight. So you can spot it. If you pull on it and it quits doing it, you don't know what you did. Bad plan, right? All right. All right. Components that move, like brake pedals and shifters, sometimes get problems like that because they bend those wires again and again every time you apply the brake or, you know, operate the shifter or something. This picture right here was taken on a 2006 model Chevrolet Impala that I may mention later in another PowerPoint, but she says, I can't get my car out of gear. So what's the first thing that comes into your mind? It cranks it up just fine, huh? The brake, right?
Right.
All right, so we looked at the brake lights and they're working just fine. As a matter of fact, on that particular one, you put your scan tool on it, you look for the body computer to get a brake signal, and then the body computer tells the little solenoid to release the shifter so you can put it in gear. Well, every time she was moving the shifter, she was moving those wires that are connected to that solenoid, and it broke the wire. And this one right here, you see that? That's how you fix something like that. I basically spread those apart, strip that back, laid it on there, solder it, and then it'll slide right back into that same connector if you do it the right way. See that? And that's the right way to do that, or that's the way I've always done it. If you can't get the actual kind of connector, if you're using the original connector, you unseat it out of there, you solder that. That ain't soldered yet, but I've got it prepared to be soldered. And think about that when you're troubleshooting. Is it a component like a stoplight switch? They do that sometimes. And if the harness is configured in such a way to where it's bending it right there in that one spot, it'll break it. I mean, it does that. All right, when you're chasing an intermittent, you need to have some visual or auditory way of knowing when your harness manipulation causes the problem to go away. So you say, okay, I know I've got a short right here and it comes and goes, and so you work your test light in there so that it's actually lit up. And then you pull on the harness very gently in very small places, and you're watching that light, and when that light goes dark, you'll know you found it. And that's when you know, I was moving this little harness just a little bit when I saw that happen. And then you'll usually find out where it's scratching against the bracket. There was a guy one time that brought a van that he came over and brought it to Ford Place, and he wrote it up. And a lot of times at the Ford Place over, they would just give me, you know, free reign to, you know, talk to the customer and do the work, and then charge him whatever I felt like was fair. Not on every job, but on some jobs that were crazy like this one. He comes and he says, I've been at shops all over town. I spent $725. My van's not running right. They keep changing parts and nobody's been able to fix it. And I came to the Ford Place last because I was afraid I'd get overcharged. And so I pulled the engine cover off and I saw the big wire harness scratching against the bracket. And so all I did was, pull it back. It wasn't hurt that bad, and made sure, taped it up, made sure it wouldn't happen again, put a tie wrap on it and charged him $20. And he went on his way happy as a lark. But the thing about it is, if you pay attention to stuff, you'll see stuff other people miss. You gotta be able to look, you gotta look past what a lot of other folks are gonna see, because a lot of people feel like if something's wrong, it's gotta be a bad part. Well, a lot of times it's not a bad part, it's some kind of a wire harness issue. All right, shining a short, you could take a circuit breaker. You see that circuit breaker right there? That's a circuit breaker like this one right here. This is a 10 amp circuit breaker. See that? All right, you get a light bulb like that one, and you put on there. Kayla, are you paying attention? Light bulb like this, you put it on here, and then off the other side of it, you make a little, you got these little things you can plug in where a fuse goes and connect to that. And so you connect that up. So what am I going to see when I got a short circuit? I got power coming in one side of the fuse, going out to the place where the short circuit, that light bulb's going to light up in it. All right, this circuit breaker is like a fuse that replaces itself. Every time a short happens, it goes ding, 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 and that light will come on and go off, come on and go off. And while you got this thing on there and it's coming up, and you got to get like an 8 or a 10 amp circuit breaker. Don't get a 25 amp or you'll burn something up. But you got to get one that'll reset itself over and over again. And while all that's going on, you start unplugging components and moving harnesses, and in a minute you'll find that. There's another cool thing you can do. If you can get a really old TV remote that's got poor shielding, I mentioned this I think last semester, and you basically take your, turn your radio on the low part of the FM or AM band, because that's the most susceptible interference you can get. The old Vietnam era jets that were flying over North Vietnam would have an AM radio receiver, and whenever they painted them with radar, they'd hear a lot of static. You know what I mean? So they know when they needed to dodge an upcoming missile. But the long and the short of it is, you can use that by putting a radio on the low end of the scale, and you got to go out here to buy where your antenna is with your cheap remote, on some old cheap TV remote, and you mash that button and see if it makes static. If you've got one that makes static, you're in business. A lot of the newer ones might not. But if you hold it right close to the antenna, you'll hear the static in the radio. Then you take the circuit that's shorted, the side of the fuse that's shorted to ground, and you hook a jumper wire to the antenna and hook it to there, and then you use that remote like a short finder, listening to your radio static. And when you get to the place on the car where it's touching ground, you just raise cane, and then you can just dig in there and find that. Now, every time I ever went to an electrical school for a manufacturer, and I went to a bunch of different ones from a bunch of different manufacturers, every single time I went to one of those schools, I learned something new. Even if I'd been to a whole bunch of them, somebody always came up with something I hadn't heard at some of the other schools that was pretty cool. That was something I learned at Chrysler School one time. All right, so the shorted branch of the circuit can be identified either by the temperature of the wire, if you got a FLIR, forward-looking infrared, you can check that, or by the fact that if it, let's say it's lights, courtesy lights, and you flip down your visors, you look at all those lights, you look at these lights up here, everything is fed by the courtesy lights, you let that fuse click off and on, all of them will be coming on real dim and going back off, except the one that's got the shorted leg going to it. It won't come on. Pretty simple, right? You got that? All right. You ready for your 10-question test?
Nope.
It ain't time yet. Kirchhoff's law, first law, current law, states that current is the same throughout a circuit. That's the simplest way you can say it. You can make it real complicated by putting a big long sentence, but think about it. The current's the same throughout a circuit. Remember I told you when you're coming into the circuit at the top, if you got 10 amps coming in, you go through all the way to ground, you're going to have 10 amps all the way through that whole circuit, right? Now voltage is only going to be readable on the top part of the circuit because you're using your ground for the reference. Kirchhoff's second law deals with the fact that all the various voltage dropped in the circuit will equal a source voltage. Source voltage of 12 volts, that's going to be a series circuit, passes through a fuse, a switch, 2 volts wired in series, let's say. Each part's going to drop some voltage, but if you add all the voltage drops up, you're going to get 12 volts. You're going to get what you started with. That's just simple as pie. And you will get a chance to do some of that later. This is a refresher for some of you guys. Here's an engaging starter problem. 99 Ford Ranger, 103,000 miles, 3-liter engine, 4R44E transaxle starter sometimes engages when the key is switched on. They just switch the key on and it starts spinning the starter. You ever seen one do that? I had a student out here one time that changed the starter out on that GMC, and when if you change the starter out and you don't know what you're doing, you'll actually get the big post together with the little wire, and when you start spinning it over, it just keeps spinning. and you can't make it stop and all that kind of stuff. Well, rather than pulling the battery cable off, the student was sitting here holding the keys in his hand, sitting here doing this. Always thinking about it. I said, unhook the battery cable or something. Why don't you just let it spin and spin and spin and burn the starter up for it? Anyway, when the Ranger came in on the hook, switching the key to the run position would engage the starter. The motor would fire up, and then you'd hear the overrunning clutching the starter just raising cane, and all that stuff. And so you could turn it off or move the gear selector, and it would stop. The starter would stop. All right, so at that point, you do a short circuit somewhere between the transmission range sensor and the ignition switch. Removing the starter relay would also disengage the starter. So if I pull this out, the starter would stop spinning. I'm having to track this down. It would stop spinning when I pulled it out. All right, so with the relay pulled out when it had been spinning, I got me a little bulb, like this right here, and I put it there. And I inserted it in the coil cavity of the relay socket. It was evident a short to power was available. It was getting power from somewhere. What do we do next?
Follow that wire?
All right, so we follow that wire. It goes here, goes here, goes there, and it's hooked into all this stuff.
Oh.
All
Check
right.
the radio, unplug in
All
the
right.
radio, see if it's still
Let's see.
doing it. Unplug the central timer module.
That's what you're thinking the right way. When the ignition switch is in start, the start terminal on the ignition switch carries power from the battery through fuse 24, through the neutral safety switch, all the way to the starter relay, which energizes and spins the starter. And of course, the starter relay is hardwired to ground here, so you're turning that to the start position, and it's never supposed to have any power until you get there. But on this one, as soon as you turned it to the on position, it was basically like in the run position, it would go to spinning the starter up a storm. All right, so now let's see what we did. All right, so where might the problem be? We experimented while the test light was glowing, and that revealed the fact that removing fuse 20, random fuse snatching was what we did here, would cause the problem to go away. That fuse right there, when we would pull that fuse right there, the problem would stop. So that's telling us the bulb would go dark when we pull that fuse. All right, so we turned that to run. Somehow it was feeding over here, you know, and it's going through here. It never was supposed to make it to this, but either here or here, it was crossed up, or maybe the wires or something, you know, crazy thing. Light would go dark there. All right. All right, since pulling fuse 20 killed the short, it was possible the circuits 1000 and 102 were shorted together. Maybe that circuit 1000 was back feeding the ignition switch, run power through fuse 28 with the starter relay coil. Who knows, you know, if you short it out, it would come back over here and go down there. All right. And so here's what the two circuits look like. There they were, circuit 1000 and 1002 enter the CTM connector right here. And incidentally, on that truck, if you pull the radio out, the central timer module's on the left over here. That's it's fairly easy to get to on that one. All right, so looking at the schematic, the wires aren't shorted together. If they're not shorted together, and we determined that they weren't, what else could it be? All right, so what are you thinking? We could have a bad radio, we could have a bad central timer module, couldn't we? I mean, I simplified this as much as I could. Kayla's going to sleep over there. All right, as I examined the schematics, I started wondering why did the CTM module and the radio need to know the ignition switch was in start? How do you determine that? This is an electronic circuit. Well, to a symptom chart pinpoint test in a radio section, I found an error. According to one particular test step, the circuit in question, circuit 1000, fed through fuse 28, has to be juiced up before the radio will work, but that wasn't true on this truck. You could pull fuse 28, the radio wouldn't be affected, but the problem would be. So I removed fuse 28 and the radio still worked. But the further research revealed the only reasons that the GEM module needed to know that circuit was eliminated is because it interfaces with the remote keyless entry, and the shop manual reads this way. The GEM illuminates the interior lamps when an unlocked signal is received from the remote anti-theft personality module, RAP module, right? All right, you know, RAP module is one of those modules that says, well, I'm glad you called, but I'm not, you know, but anyway. 25 seconds have elapsed since the illuminated entry feature was activated and the courtesy lamp feature is not activated. If the GEM receives a request from the RAP module remote transmitter lock button pressed, the courtesy lamp feature is not activated. If the ignition is in run or start, the courtesy lamp feature is not activated. This one here did not have RAP. Didn't have it, didn't need that. So RAP on a Ford stands for Remote Anti-Theft Personality. On a GM it stands for Retained Accessory Power. Isn't that interesting? Both of them have RAP modules, but they do different jobs. Now that's older ones, this is not like today. They got body computers and everything now. The CTM gem module cost $200. The radio could have been disconnected to see if the problem returned, but as it was, since fuse 28 wasn't needed on this vehicle, we jerked that fuse out and sent it on its way. Never saw the problem again. Now, if somebody came along and stuck fuse 28 back in there, they're probably going to have trouble again. Now, to be perfectly honest, the problem may have been in the central power module, may have been in the ignition switch, I don't know. But the long and short of it, we straightened it right out by just pulling that fuse out of there. All right. So, get good at reading schematics. There's times when simply reading the description and operation section of a system is crucial to understanding a repair path. Recognize that, live it, learn it. Knowledge is power, and whenever you try to guess your way to a fix, you usually fail. Either that or you just put a switch on it to run the fan and run it directly to the battery, and that's crummy. Okay, write the answer to that question. You got 10 seconds.
Jimmy.
9, 8, 7, 6.
Wait, what?
Say that, the Ohm's law. I know how to do it, but I don't know.
One blank pushes one blank through one blank.
I don't know how to spell it. So
I put most of the words in there. All you got to
Make
do
it
is add those
simple.
words.
I don't know if I can make it simple or not.
You're a chum. What?
Okay.
These are all fill in the blank questions, so you're not going to be able to just guess at a multiple choice, okay?
We just write the words that go in this book.
Exactly, that's what you do. Number 2, what does RAP stand for on a GM?
Oh, God.
What? You weren't listening when I told you just a minute ago?
I listened, but I just didn't remember.
On a Ford, it stands for Remote Anti-Theft Personality. But you'll just get it wrong if you can't remember what it stands for on a GM. You were watching me. You and Tyler are good at just focusing straight on me when I'm talking. I'm noticing that. Him and Tyler are both like that. They look straight at me when I'm talking. They don't ever look anywhere else. 5 more seconds. 4, 3, 2, 1. All right. Where is the best place to find technical information about the way a system or a subsystem operates? Hint, it's not in the owner's manual.
All that.
You got to do better than that. I just put the answer on. The answer to this question was like 2, 3 slides back. 4
Description
slides
and
back.
operations.
That sounds like a good answer to me, so why don't you write it down?
Yeah, that's the answer.
Hurry up, Charles.
We got it, go to the next one.
What does Kirchhoff's first law state? You weren't paying attention, were you? I don't need to know this. So
Hungry.
Fill in the blanks.
I know, you
We
like,
get answer choices.
you basically like
I
doing
can't
multiple
spell.
choice. Yeah, you know how the multiple choice questions work? You just got 4 quadrants on the clock. You go, just pick one of these. Yay! You know, just pick one. Yeah, if you have to fill in the blank, this is the way they used to teach school back in the early part of the 20th century. You had to actually know what you were talking about or you'd fail the test. Although these tests are harder to grade whenever you're doing a fill in the blank test. 5, 4, 3, 2, 1.
Ah, you didn't get.
Sorry, I missed it.
You went too much.
Sorry. What is Kirchhoff's second law
Just go to
state?
the next one.
Yeah, I remember this.
You know what second law is either, do you?
No.
No.
You are supposed to know. You know what you need to do? You know what you need to do when you go in there this afternoon? You need to find Will. I don't know how often you see him. He's probably busy as he can be. Or we'll say, Will, can you tell me what Kirchhoff's law is in regard to electricity? He may know, he may not. You know what I mean? But he probably knows because he is very, very, very sharp.
I'll tell you.
You know, there's not much that he don't know, so he'll probably know. All right. What's the amp rating of this fuse? Better know your fuse colors. The best way is to figure out what it's not.
I got my phone. I already know what it is.
Kayla's over here just Googling up a storm.
I already got it.
There you go. All right. Question 7. Dotted line A means what? Dotted line A, this is dotted line A.
That means it's not all, I'm right, I just didn't wanna say it loud.
Dotted line A.
Oh.
Dotted line B means what?
Oh,
What's dotted line B mean?
that there, like, it's.
Huh?
I'll show the same ground.
You are supposed to know this.
That's supposed to know a lot of things, bro.
There's no clue work for an answer. That's what we got with.
And what does dotted line C mean? They're not gonna put a dotted line on there if it doesn't mean anything. We gotta hurry so we can do the answers. We got under 4 minutes.
Just send it.
What does this symbol represent on a wiring diagram?
Oh, what's that thing called?
We can't tell you.
You just showed me a while ago? There it is. I ain't you.
What?
All right, let's go backwards through the questions.
I'm about to order.
Let's go backwards through the questions. You ready?
Yeah.
Watch. That's a thermistor.
Oh,
Intake air temperature and a coolant, transmission oil temperature. It's a temperature sensor is what it is. When you see a resistor with this right here, that means it's going to change resistance. By design, it's supposed to change resistance. And if it's negative temperature coefficient, it'll actually have less resistance as it gets hotter.
I don't know.
Okay, now let's back up.
I heard you.
All right, what does that line mean?
Oh,
That means all these switches in there move together. That is a ganged switch. Ganged switch. All the switches, a switch with a whole bunch of contacts, and they all move together at the same time.
that's racist.
All right, this right here, watch this. That means all of these, you see this connector, C202, that means all of these
Power
wires
sensor.
go through the same connector shell. All of these wires go through the same connector shell. And A basically means you're not seeing the whole
Seeing all of
component.
it. Boom.
You're not seeing the whole component, boom.
Charles.
What's the rating?
15.
What? A 15 amp fuse is blue.
How much?
A 20 amp fuse is yellow.
That is yellow.
That's orange.
Well, you should do a better job with the color.
45. Looks like yellow.
No, that's orange.
That's yellow.
You just.
It's orange.
What's that? Okay. Okay.
Orange
What
is,
color is it?
orange
five.
is orange. It's 40 amps.
40.
Was it
You ever
need
seen a
better
fuse
color?
that size that was 40 amps?
I said 30.
There ain't many of them out there, but you'll see
I've
them.
never seen one.
You will. Don't worry, you will. That's a 40 amp fuse. Kirchhoff's second law states that all the voltage drops are equal to the source voltage.
Oh.
That ain't hard to remember. I wasn't trying to be complicated.
Equals what?
It was
Well, the
all of the
source.
voltage drops equal to source voltage.
That's what
All voltage drops in a closed circuit equal to source voltage.
The next one is parallel.
Kirchhoff's
circuits,
law, first law states what?
I think it was a parallel circuit.
Current is the same all the way through a circuit.
circuit.
Current's the same all the way through a circuit. Where's the best place to find technical information? Description and operation. What does RAP stand for in a GM vehicle? Anybody get that right?
Nope.
Is it
Retained accessory power.
Retained
Retained
accessory
accessory
power.
power.
Retained
I
accessory
got power
power.
up.
I bet if I tried to get Sierra to say that with me, she wouldn't do it, would she? All right, right Ohm's law. Who wrote it?
One ball pushes one after one on.
Very good. Outstanding performance. Yay! Y'all did well. All right, wait a minute. Let's do this one more time.
Hardly.
Hold on. I'm gonna leave this slide right here again. Burn that in.
Says current is the same.
Let me take a picture of it.
Yeah.
Burns the same throughout a circuit. Voltage law deals with the fact that all various voltage drops in a circuit will equal the source voltage. And he takes a picture of the slide. There's nothing wrong with that. Outstanding performance.